Vectors, Lesson 1. In this lesson, we will learn about definition of vector, vector notation, negative vector, zero vector, and equal vectors. Definition of vector. Vector is a quantity that has both magnitude and direction. Scalar is a quantity that has magnitude only. A vector can be presented by a line segment with an arrow known as a directed line segment. The diagram shows a directed line segment AB which show direction from A to B. Thus, this is vector AB. Vector notation. Vector can also be presented with the notation as shown as below. There is an arrow that shows the direction of a vector from A to B, whose magnitude is AB, or letters with bold printing, or by a small letter with a line under it, or a small letter with bold printing. Magnitude of the vector or the length of the vector can be written as the symbol as below. Negative vector. Negative vector of vector AB has the same magnitude as vector AB, but its direction is opposite to the vector AB. This is a vector AB, direction from A to B, while this is vector BA, direction from B to A. Thus, negative vector AB is vector BA. For example, two trains A and B move past each other at two parallel railways at the same speed but different direction. The velocity of train A has a positive value, while the velocity of train B has a negative value. Zero vector. A zero vector is a vector whose magnitude is zero. It is denoted by this symbol. For example, a race car is moving in the round-shaped track. The starting point and the terminal point of the moving car are the same. Thus, the vector for displacement of the race car is zero vectors. Equal vectors. Two vectors are equal if both the vectors have the same magnitude and direction. Example, Rakesh and Fauzi are riding bicycles at the same speed and in the same direction. The velocity vector v for both movements are the same. Thus, velocity vector Rakesh is equal to velocity vector Fauzi. Let's do some exercises. Question 1. The diagram on the right shows a parallelogram ABCD. The points P, Q, R, and S are the midpoints of AB, BC, CD, and DA respectively. Given that vector AS is vector A, vector AP is vector B, and vector AJ is vector C. State the vectors for the following in the terms of vector A, vector B or vector C? E. Vector SD, direction from S to D, which is same direction as vector AS. Then vector SD is vector A. B. Vector CJ, direction from C to J, which is opposite direction to vector AJ. Then vector CJ equal to negative vector C. C. RJ. Vector RJ showing the direction from R to J, which is opposite direction to vector AS. So vector RJ equal to negative vector A. Then number D, vector JQ, direction from J to Q, which is same direction as vector AP. Then vector JQ is vector B. Question number 2. Find pace of same vectors in the diagram. Same vectors means the vectors have the same magnitude and direction. Okay, number 1. Vector A has the same direction and same magnitude as vector D. Vector MN has the same magnitude and direction with vector CD. Vector C is equal to vector F. Vector B is equal to vector E. Vector EF has the same length and same direction as vector KL. Vector GH has the same direction and same length as vector AB. Thus, vector GH is equal to vector AB. Question number 3. The diagram on the right shows the regular hexagon ABCDEF. State the negative vector for the following vectors. Number 1. Negative vector EF means it's the same length as vector AF but different direction with vector AF, that is the vector DC. Negative vector FE has the same magnitude with vector FE but different direction with vector FE, that is vector CB. Negative vector ED means the vector has the same length as vector ED but different direction or opposite direction to vector ED, that is vector BA. Question number 4. The diagram on the right shows vector F that represents the force applied on an object from J to K. Find the magnitude of vector F. To find the magnitude of vector F, we can find the length of JK, where we can form a right angle triangle. This right angle triangle will have vertical distance 4 cm and horizontal distance 2 cm. Thus, the magnitude of vector f equals square root of 2 square plus 4 square, which is equal to square root of 20. That's all for this lesson. Thank you.